Let's work a simple projectile motion problem. The two equations that you'll use more commonly than any other of the 4 or 5 equations that deal with motion in plane are these two equations. Show you how to predict the future x and y coordinates of a projectile. The x coordinate is equal to the x component of the initial velocity times however much time you wish to go by, t. The y coordinate is equal to the y coordinate of the initial velocity times t minus 1/2 gt squared, where g is 9.8 meters per second per second. So we have the following situation. At the top of the building, this is the building of undeclared height. An object is thrown out and down at an angle initially of 30 degrees with respect to the horizontal. The launch speed, the throwing speed, 60 meters per second. What we wish to do eventually is to predict where the particle will be, where the object will be after a certain number of seconds. But to do that, to get the x and y coordinates of the particle, we will need to know the x and y components of the initial velocity vector. Here then is SOHCAHTOA in action. The x component of this vector is the shadow it casts on the x-axis, which is this side there, which is hypotenuse 60 times the cosine of 30 degrees, 51.96 meters per second. The y component of the velocity is the negative of the shadow that this arrow casts on the y-axis. It's a negative of it because the shadow shown there lies on the negative side of the y-axis. And so we have this distance here times -1. It's the same as that distance, which I prefer to look at. It's the leg of a white triangle shown here. It's the side opposite the 30-degree angle, so sine is operational. And so it's hypotenuse 60 times the sine of 30, and don't forget the negative sign for the reasons I gave earlier. Final result, -30 meters per second. Now let's predict what the x and y coordinates of this particle will be after a certain number of seconds. I'll remind you, or say for the first time because I didn't say it initially, that the origin of our xy coordinate system is taken to be the top of the building. Positive x-axis to the right, positive y-axis upward, negative y downward. So our particle will end up somewhere over here in the 4th quadrant. What will be its xy coordinates when 1.2 seconds have gone by since the object was thrown from the roof? Well, we already have the x equation shown here, ready to go. We've already calculated V0x, V0x. V0x is 5196, and we multiply times 1.2 seconds to get that number. That's the x coordinate at that instant. The y coordinate is found using this equation and this number there. -30 times 1.2 minus half of 9.8 times 1.2 squared. Y coordinate is -43.06. The problem is solved. Very simple projectile motion problem. I'll try to create some more difficult problems for you, or for me to show you in the near future.